In 1874, a seemingly ordinary paper changed everything. Georg Cantor introduced a radical idea: infinity comes in different sizes. This concept shattered the long-held beliefs of mathematicians. For centuries, infinity was treated as an untouchable enigma, a philosophical question rather than a mathematical one. But Cantor's revelation opened the doors to a new realm of understanding. Did you know that Cantor's ideas sparked fierce debates and even personal conflicts among mathematicians? It wasn't just about numbers. It was a battle over the very foundations of mathematics. Before Cantor, infinity was considered a potential concept, something that could keep growing but never be fully realized. Imagine a number line filled with gaps. Between any two natural numbers, you could zoom in and find infinitely many fractions, yet some numbers, like the square root of 2, would always remain elusive. In 1872, two brilliant minds, Richard Dedekind and Georg Cantor, began to challenge this notion. They were on a quest to construct a complete number line, one that would include every possible real number. They realized that infinity wasn't just a distant concept, it was embedded in every interval of the number line. This was revolutionary. During a summer vacation in a Swiss village, Cantor and Dedekind met and exchanged ideas. Their correspondence would become famous, filled with mathematical questions and groundbreaking insights. Cantor asked Dedekind about the nature of sets, collections of numbers that could be finite or infinite. To illustrate this, think of pairing even numbers with natural numbers. At first glance, it seems like there are half as many evens, but when paired, each even number matches with a natural number, proving they are the same size. But what about the real numbers? Cantor posed a radical question: are real numbers countable? Dedekind responded, suggesting Cantor focus on the interval between 0 and 1. If he could prove that this small section of the number line was countable, it would be enough to prove the whole line could be counted. Spoiler alert: Cantor proved that real numbers are uncountable. He showed that for any list of real numbers, you could always construct a new one not on the list. This meant some infinities are larger than others. Imagine the implications. If one infinity could be measured as larger, it opened a vast new realm of mathematical exploration. But not everyone was ready to accept Cantor's radical ideas. Leopold Kronker, a prominent figure in mathematics, was staunchly against the concept of infinity. He believed in purifying mathematics to only what could be constructed from natural numbers. Cantor faced a tough challenge: how to get his ideas published without provoking hostility. He cleverly crafted a paper that disguised his groundbreaking argument. He first presented Dedekind's proof almost verbatim, but then slyly included his own results about real numbers. The title of Cantor's paper, "On a Property of Algebraic Numbers." You can imagine him wishing he could title it, "There are different sizes of infinity, look at this crazy stuff." Cantor's paper was published under his name alone, and over time, his ideas took root in the mathematical community, laying the foundation for set theory. Today, set theory is the language of modern mathematics, influencing everything from computer science to physics. But here's where the story gets more complicated. While Cantor is celebrated as the sole architect of set theory, recent discoveries reveal a deeper narrative. Letters between Cantor and Dedekind were thought to be lost forever, but in 2024, mathematician Demian Gues embarked on a quest to find them. His search led him to an archive in Germany where he uncovered a binder containing the missing letters. One letter, dated November 30, 1873, contained Dedekind's proof that Cantor would later publish without attribution. This revelation shocked the mathematical community. Can you believe it? Cantor effectively took credit for Dedekind's work. The newfound letters highlight the collaborative nature of mathematics, shaped by ambition, friendship, and sometimes betrayal. The story of Cantor and Dedekind is not just about numbers, it's a reminder of the humanity behind mathematical discoveries. Gues hopes these letters will reshape the narrative of one of the greatest discoveries in mathematics. Instead of viewing Cantor as a lone genius, we can appreciate the collaborative efforts that led to such groundbreaking ideas. So next time you ponder infinity, remember, it's more than just a number. It's a complex web of ideas, friendships, and even rivalries. How many more hidden stories lie beneath the surface of mathematics waiting to be uncovered?